So now we're going to continue looking at function notation, but this time we are going to use graphs. A lot of vocabulary that is super important. So a reminder, discrete is distinct or disconnected set of values, very specific points. All of the sequences that we have looked at up until this point are discrete because there were specific values. Continuous is when your values are connected. That doesn't mean that it has to go on forever. It can have a beginning and an end. It's just there are values in between. When something is continuous, we will use interval notation. When you are doing interval notation, since domain is X, you are going to write the values that exist from left to right, and the range will be written from bottom to top. You will need to decide whether you are going to use parentheses or brackets. When you're writing interval notation, you will not use braces. It's either parentheses or brackets. A parenthesis means that you are approaching something. Whereas a bracket means that it equals something or it ends. And that's written at the bottom of this page so that you have it for your notes. Set notation will be used most often for discrete graphs, but it can be used for a continuous graph using inequalities. So we'll look at both of those as we work through there. But you'll only use braces for set notation. Okay, so this is a great way to talk about domain and range on a graph and the different ways that the notation can look. So we're going to do set notation and interval notation for all of these. So we're going to start with interval notation, I think. So for the first graph, that is a line. It has arrows on both ends. That means it's going on forever. So when we go to do domain, we're going to look left. The question I always tell students is ask yourself, does it go left forever? Because it has an arrow on it, yes, it goes left forever. And if something goes left forever, that means it is approaching negative infinity. You can't ever get to negative infinity. So it can't equal negative infinity, it approaches, so that's why we're going to use a parenthesis. Now ask yourself, does it go right forever? There's an arrow on the right side, so yes, it goes right forever. And if it goes right forever, then that means it approaches infinity. And again, because it's approaching infinity, we use a parenthesis. We cannot equal infinity. So the domain of that line is negative infinity to positive infinity because it goes left forever and right forever. In words, that means that all real numbers work for this domain. So sometimes instead of seeing that interval notation, you could see words that say all real numbers. I'm just going to use the abbreviation for numbers just for space. As far as set notation, it's not as common for set notation on one like this, but we know set notation is what we've been doing, X such that X, and here's why it's not as common. We haven't really done this yet, so I would expect on the test it would either say, negative infinity to infinity or all real numbers. X, there's a symbol for real numbers. So the first symbol that we're going to use is kind of this E looking thing. That's an element of, and then the symbol for all real numbers is kind of like an R but with two lines on it. Again, not as common to see that notation, but that is how you would technically write set notation for a line that goes left forever and right forever, or an E. It doesn't have to be a line, it could be anything. For our range, since our range is Y values, we are going to look bottom to top. Remember that domain and range have to be in ascending order. So you can't go top to bottom because that would be descending. You have to go bottom to top. So ask yourself, does it go down forever? Well, there's an arrow pointing down, so that means it goes down forever, so that would be negative infinity. Does it go up forever? Yes, there's an arrow pointing up, so that would mean positive infinity. And again, because it's approaching negative infinity and positive infinity, we're using parentheses. So the domain and range for this one are the exact same as far as interval notation. And what that means is it's all real numbers. Your line will pass through every single value as it continues to go. That doesn't mean it's going to pass through every single point on the coordinate plane because it's a line. It doesn't. But at some point, x will be 20. And at some point, y will be negative 56. And there will also be decimals and values in between. There can be 1.5 on there. And that's why we're using interval notation, because if we just said 1, 2, 3, 4, like we've been doing, you're saying that it can't ever equal 1.5. But if you look at the graph, you could go to 1.5 on your graph. Inset notation is going to look the same, except for we're going to change the x's to y's. Y such that y is an element of all real numbers. For the second graph, it is a line segment. So it doesn't go forever. It has a very beginning, or it has a definite beginning and a definite end, both left and right, and both bottom to top. So for the domain, focus specifically on the x's. So if we're looking, does it go left forever? The answer is no. Its furthest left point is at negative 6. And there's a physical point there, which means it equals negative 6. So we will use a bracket. Does it go right forever? No, it doesn't have an arrow. It ends where x is 8. And again, there is a physical point there. So when I write my domain like this, I'm saying the x can be anything between and equal to negative 6 and 8. This is not, like negative 6 is not x and 8 is y. Everything in domain is x. So x can be anything between negative 6 and 8. To write that in set notation, we use our braces, x such that we're going to use an inequality. Negative 6 is less than or equal to x, which is less than or equal to 8. Anything between and equal to negative 6 and 8 is what x can be. Can't be 10 because there's no place when x would equal 10. For the range, same idea, but now we're looking bottom to top. Does it go down forever? It does not. The lowest that it goes at that point is negative 4. So it starts at negative 4. And the highest that it goes is positive 4. So it's between negative 4 and 4. Again, we're using brackets for this one because it equals negative 4 and 4. To do it in interval notation, we are going to do y such that, and then because it falls between negative 4 and positive 4, we write our inequality. Make sure you're using braces. Again, both of those are perfectly fine to write. You just need to be prepared because questions might be in interval notation or they might be in set notation depending on the type of question they're asking. The third graph is kind of a mixture of the first two. This is a ray. It has, on the left side, it has a definite point, but on the right side, it continues forever. So when we go to do the domain, does it go left forever? No, the furthest left it goes is negative 8. There's a physical point there, so it can equal negative 8, so I'm going to use a bracket. Does it go right forever? Yes, it does. There is an arrow going to the right forever, so that means infinity. I approach infinity, so I use a parenthesis. That would be your interval notation. Set notation is going to use braces. Domain is x, so x such that. All right, so this doesn't have a beginning and an end, right? It has a beginning, no end, so that means x can be any number greater than or equal to negative 8. You got to make sure you use the right inequality because it's going to the right forever. That means greater than or equal to. Notice kind of the arrow is pointing right on the graph, and so is the inequality. It is also pointing right. For the range, now we're going to look bottom to top. Does it go down forever? Yes, it's got an arrow going down, so that means it's going to negative infinity. It's approaching. Use a parenthesis. Does it go up forever? No. It has a highest point, and that highest point is at 7. There is a physical point there, so it can equal 7, so I use a bracket. That is your interval notation. Anything below 7 or equal to 7. For our set notation, use our brace, y, such that this time everything falls below 7, so we're going to use less than or equal to 7. Okay, so just to kind of get you a little bit familiar with what domain and range look like in both of the notations, now we're going to put that into some context. So Marcos is taking 5 of his friends to the Georgia Aquarium for his birthday. The cost for admission is $21, and it also costs $21 to park. The graph below shows the total cost that Marcos spent to go to the Georgia Aquarium. Write the recursive rule to represent the sequence. All right, back to that vocabulary. Recursive means tell me what the first term is. Be careful. Make sure you're looking when x is 1. Don't look when x is 0. That is the 0 term or the y-intercept. We need the first term. So the first term, if we look at the graph, is 42. That means if just Marcos goes, it's going to cost him $42 because he's got to pay for parking and he has to pay for his ticket. Now we write the rule of how you find a term, a sub n. I'm going to use any previous term, and I'm going to add $21. Okay, now we're going to write the explicit rule, but this time we're going to use function notation. So f of x, for the explicit rule, we do the first term, and then we add the common difference times n minus 1. But it says slope-intercept form. Slope-intercept form is y equals mx plus b, right? And m is your slope or your common difference. And we know that that's 21 because it's $21 per ticket. B is your y-intercept. Because we have a graph, we can find that the y-intercept, or we can see that the y-intercept is 21. So we didn't have to write it in the explicit rule and rearrange it. We could have, right? It would work the same. So now we're going to do domain and range. And here's where you really have to start thinking. So is this discrete or is this continuous? Okay. Are there values in between? Well, we can look at the graph and see that there are not values between. But in the context of the problem, let's say they didn't give you the graph. Let's say they just gave you this scenario. Marcos can buy 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets, 6 tickets, because it's 5 friends and Marcos, and that's it. He can't buy any other tickets. He can't buy more than 6 tickets. He can't buy negative tickets. He can't buy partial tickets because there are a specific number of people going. So the domain has to be written in set notation. So x such that, and then you are going to list the x values. Now, it doesn't really make sense to have 0 be included because that would mean that they don't go at all. But technically, you could include 0, which would mean that he's just paying for parking. Oops, I forgot my x such that. Go back. X equals 0, 1, 2, 3, 4, 5, 6. And again, to me, this is one where 0 is debatable because if he buys 0 tickets, that means he's just going and he's just paying for parking. Maybe they do that and they decide, you know what, let's not go to the aquarium, let's go to Centennial Olympic Park and play Frisbee or whatever. I guess it's technically a possibility, so that's why I'm including it. For the range, we're going to look at the y values, which is the total cost. So make sure that you use y. Oops, forgot my brace. Such that y equals, if he buys no tickets, he's paying 21 bucks for parking, then 42, then 63, then 84. And I'm just using the graph to get my numbers, 105, 126, and then finally 147. All right, and then finally write a sentence to describe the meaning of f of 5. So f of 5, you can do it two ways. The easiest way is probably to look at the graph. So 5 would be your input or your x or your number of people. So we're going to go up and we can see that point right there, 126. So f of 5 is asking how much does it cost for 5 people? So that's what you are going to write in your sentence. And you can say it a couple of different ways. I'm going to put the cost of 5 people, and that would be, let's see, what does that say? $126. You could also plug 5 into your function. You could do 21 times 5 and then add that $21 in for parking. You get the same answer. You could look in your domain and range and go to where it is for 5 people, and you can see that it's 126 as well. So 3 ways technically you could have done this. Easiest should be just looking at that graph though. All right, on number 3, we have Vivian's cell phone loses battery power throughout the day. The battery percentage on her phone is shown in the graph. All right, so we're looking at the graph. We can see that at 0 hours, it was 100% charge, and after 5 hours, it's completely dead. So we're going to write the explicit rule to show the battery percentage B of X in relation to hours. So let's call it B of X. And we're going to go ahead and do slope-intercept form. Remember, slope-intercept form is y equals mx plus b. M is the slope. In all of the problems that you've had so far, you've been given the slope, either by identifying that common difference, because remember, common difference and slope are the same thing. You were told in words somehow, like $21 per ticket in that last problem, or you were able to visually see it. This one you can visually see, but you're going to have to think about it a little bit more. So let's see, I'm going to kind of just put some points on this graph to make it a little bit easier for us to see it. Essentially what we have to figure out is how much power or percentage is this battery losing every hour. So if we look, we can see it starts at 100, after 1 hour it's at 80, then it goes to 60, then it goes to 40, then it goes to 20, and then it goes to 0. So if you write it out, that may be a better visual way for you to see it. It is decreasing by 20% every hour, so the slope or the common difference is negative 20. You could also use your graph and count down 20 over 1. You will have to pay close attention to scale. Don't just say, oh, it goes down 2 over 1, and so it's negative 2. Going down 2 is like going down 20 because you're going from 100 to 80. And then that y-intercept, we can see on the graph, is 100. So again, like this time you had to come up with that information from the graph. We could have said, you know, she starts the day at 100% and her phone loses 20% every hour. Right? I could have given that to you in words, but here we wanted you to extract that from the graph. So now we're going to look at domain and range. This is continuous. That phone is continually losing power until it's dead. And you can see on this graph, it's connected. It's just not, you know, specific points. So we can write this in both interval and set notation. All right, so let's start with domain. Domain is X, which is hours in this problem. Does it go left forever? No, it has a very distinct starting point, and that is 0 hours. So On the left side, it's going to be 0. We're going to use a bracket because that's a physical point on the graph. Does it go right forever? No, it stops at 5 because at 5 hours, that phone is dead. So an interval notation should be 0 to 5, both in brackets. That means anywhere between 0 and 5 hours, it has a charge. But beyond that, there is no charge. In set notation, we're going to use our braces, x, such that, and because it's between two numbers, we're going to use an inequality. 0 is less than or equal to x, which is less than or equal to 5. For the range, we are looking at the battery percentage. Does it go down forever? No, it doesn't have negative battery percentage. It stops when it's at 0%. Does it go up forever? No, it stops when it's at 100%. Your battery percentage can be anywhere from 0 to 100. In set notation, since it's range, we'll change the x's to the y's. And again, because it's a range of values, it has a beginning and an end, we're going to use an inequality. 0 is less than or equal to y, which is less than or equal to 100. When you're writing it as an inequality and it's in between two values, make sure you put the smallest number on the left and then the biggest number on the right. Again, ascending order. And then write a sentence to describe the meaning of B of 4. So that would be the battery at 4 hours. So we can plug into the equation, or to me, the easiest thing to do is go to 4 hours and look for the point. That's at 20%. So after 4 hours, Vivian's phone will be at 20%. And you can say that in a couple different ways. The key is that you're using labels. Don't just say 4 and 20. Make sure you say 4 hours, 20%. Okay, a sentence. All right, for our last problem, we are looking at Mr. Minton, who planted a tree in his yard when he moved to Georgia. The tree he planted was 2 feet tall, and our graph is showing the projected growth of the tree over years. So the first thing we're going to do is we're going to write our explicit rule, and we are going to use, it says h of x, so the height after x years. Again, we want to do slope-intercept form, so we need to know the slope and we need to know the y-intercept. The y-intercept is easy. You can see it right there at 2. The tree started at 2 feet tall. What we don't know is how much does it grow every year, but we can get that from the graph. So you can do it just by looking at the graph, or if it's helpful to write out the values, you can. So we know at 0, it's 2 feet tall. After 1 year, it's 3 feet tall. After 2 years, it's 4 feet tall. After 3 years, it's 5 feet tall. 4 years, it is 6 feet tall. So hopefully this pattern's pretty clear to see. It is increasing by 1 foot every year. That means your common difference, or your slope, is 1. So 1x. And then the y-intercept is where it started at. The 0 term, the y-intercept, that's 2. Now, typically in high school and any standardized testing you're going to take, you are probably not going to see that 1 sitting in front of the x, because 1 times x is just x. So I am going to get rid of that 1. Okay, but so you know there's an understood 1 in front of that x. Now we're going to look at domain and range. Again, you have to think about continuous or discrete. The tree is going to grow in between the years, so this is going to be continuous. You can see in the graph that the points are connected. It wasn't just distinct points, so that also means it's continuous. So we're going to start an interval notation. Does it go left forever? No. For our domain, we're talking about x, or the years. He planted the tree at 0 years, so this is going to start at year 0. Does it go right forever? Yes, you can see that arrow on the right end, and your tree is going to continue to grow. So because it goes right forever, we're going to use an infinity. Remember that you approach infinity, you can't equal infinity, so we use a parenthesis. For set notation, we use our braces, x, such that. We're going to use an inequality, but this time there's only going to be one inequality because there's not a definite beginning and a definite end. Okay, so x, and it can be anything greater than or equal to 0. Okay, your years can be anything from 0 or higher. For our range, we're looking at our y or our height. Does it go down forever? No. The tree started at 2 feet tall. So we're going to start at 2. Does it go up forever? Yes. Our tree is going to continue to grow, so we're just going to put infinity. Now we could, argue, well, what if somebody cuts it down? All of those, there's a lot of valid points, but we don't know when that's going to be, so we're just going to assume it continues. For set notation, we use our braces, it's range, so we use y, and y can be anything, or the height can be anything greater than or equal to 2. That's the smallest it's going to be, but then it'll only grow from there. And then finally, write a sentence to describe the meaning of h of 7. That means the height after 7 years. So a couple of ways you can do it. You can go to the graph, go to 7 years and go up, and you can see that point, thankfully. You may not, if I would have said 10 years, you couldn't see that point. You could also keep the pattern going, do 5, 6, and 7, and just add, 1 a few more times, so 7, 8, 9. Or the other thing you could do is you could plug into the explicit rule. You could do h of 7, plug the 7 in for x, and 7 plus 2 is 9. So in this particular problem, 3 different ways to figure out h of 7, but that tree after 9 years is going to be, the tree after 7 years is going to be 9 feet tall. So let me get a sentence for that. After 7 years, the tree will be 9 feet tall.